In this video, we are going to create the assembly for our road. In Civil 3D, the assembly is the backbone for creating the corridor for our road. So in this video, we are going to see how to create the assembly. The assembly is very important as it will define the cross-section of our road. So when you look at this image, we can see the road. Here is the center line of our road. Then we have the lanes both on the right and the left. At the end of this lane, we can see we have the shoulder, and then after the shoulder, we shall have what we call the daylight beyond this cut. So there are some areas where we shall have cut, and then some areas where we shall have fill, but where our design terminates, we shall always have what we call the daylight. We're going to discuss that later on. But for now, we're going to see how to create the lane, the shoulder, and then later on we shall see how to create the light. So let's get back to, let's first look at the cross section of our road. So we are going to create, our road is going to have such a cross section whereby we have the center line here, we have the lane width. Our lane will extend into the shoulder by 0.3. I think we talked about that when we are creating the offset alignment. So we shall have the camber. Our camber is going to be 2.5%. And then our shoulder is going to have a slope of 4%. Our shoulder width is going to be 2 meters. Then our lane will be 3.5, but with an extension of 0.3. So that will make it about 3.8 meters. And we're going to have a 2-lane road. So let's first get back to Civil 3D and we see how we are going to create an assembly to represent this cross-section of our road. In Civil 3D, assemblies can be created from the Home tab, and then you come to the Create Design panel. On the Create Design panel, the assemblies are found just here. So you can hover your cursor here and you see assembly. This is an assembly, though it might appear a bit different depending on which version you have, but it's just around here on the Create Design panel. So once you are there, click on that and then click on Create Assembly. So you're going to get this dialog and then it will ask you for the name of your assembly. So the name of this assembly, let's call it Roadway Assembly. It's always good to give it a name that describes what it represents, because if you have so many in a real project, you will have different assemblies, and if you have so many of them, those names can end up confusing you. So it's a good practice to give it a name that represents that describes what it represents. You can add a description in case you want, but I'm not going to add. Then the assembly type. So let us choose the assembly type. So we have undivided ground road, undivided planar road. Undivided ground would mean that the road is not divided. I mean, it is just a single carriage, but it has a crown. Divided crown, this one means you have something like a dual carriage, which is separated by something like a median in the middle. Then divided planar, you can still relate. It's divided, but it's planar. It doesn't have camber. Then railway, we are not going to design railway. And so that means for our case, we're going to have a 2-lane road with a single carriage. So we are going to have undivided ground road. So let's choose this for our type. Then the assembly style. Let's leave the assembly style as basic. The code set style, we shall talk about codes later on, but let's just leave it at that. Leave the layer as that, C road as same, and then just click OK. So when you click OK, Civil 3D will prompt you to specify the baseline location. So just find somewhere where there's space on your drawing area, somewhere like here, and then just click once. So when you click there, Civil 3D will automatically zoom in and show you the baseline. So we have now created the baseline for our assembly with a marker in the center. So we are now going to add sub-assemblies to this. So an assembly is made up of different sub-assemblies, which we are going to create very soon, which represents the different parts of our cross-section. So in order for us to start adding sub-assemblies to this baseline, you need to access what you call the tool palettes. So the tool palettes, you can find it just somewhere here on the home tab. Just click somewhere around here, tool palettes, or you can press Ctrl+3 to access it. So click there to access the tool palettes. And yes, it's here. So on the tool palettes, we have different sub-assemblies. Civil 3D comes with some predefined assemblies. So in some cases, if you need to use them, you can use them, but we are not going to use them in this project. We are going to create our own. So make sure you go to the Lens tab. If you can't access it from here, if you can't see it for some reason, just come here and you right click. You'll be able to see a list of all the tabs that are present on this tool palette. We have the basic, the lens, the shoulder, medians, and so on. So just make sure you look for lens and you click on that. You'll be able to see it there. So under this lens, we have lens per elevation, AOR, and so much more like you can see there. But we're going to use the lane super elevation, AOR. So click on that once. When you click on that, it will show you the properties. So you can edit the properties of that from here. You can edit the side. You can see the side. This is on the right hand side, so you can change it to left. However, for some reason you may not be able to change it from here. So if you want, you can actually change the parameters from here. But I know there could be a problem and you cannot be able to change these properties just from here. So you really don't have to worry about that. Let's first add it here, and then we shall edit that later on. So when you bring your cursor here in your drawing area, you see that it is prompting you to select a marker point within the assembly. So just come somewhere on your baseline and click just somewhere on your baseline just once, and it will place for you the lane. So this is going to be your lane. So let's first close this properties tab and then just escape once, and then click on this lane or this sub-assembly. So this is a sub-assembly. So we are going to add more sub-assemblies so that we create our roadway assembly. So when you click on it, just come here to the contextual ribbon and then you select sub-assembly properties. So I want us to edit the parameters from there. However, you could also edit them from the properties, but let's just edit them from here. So the name of this subassembly is lens per elevation, AOR. Let us change it to something like, let's change it to lane right, because it's on the right hand side. Let's just change it to lane right, and then we'll go to the parameters. So the parameters, first of all, it's on the right hand side. Let us leave it on the right hand side, don't change that. And then the width. So the width of this thing is going to be 3. Remember, it is 3.5, but we are adding an extension of 0.3. So it's going to be 3.8 meters. Then the default slope. The default slope, make sure it's negative. Negative will mean it is slanting away from the center line. So it should be negative 2.5, because we saw on our cross section we had 2.5%. Then pavement depth 1. Maybe I need to talk about the pavement depth. When you go into the structure design of a highway, we have different layers of the road. We have the sub-base. First of all, we begin from the subgrade, the sub-base, the base. We are going to see what pave 1 and pave 2 represent. So, the different layers of pavement, this is an extract from TRL 1993. The different layers of a pavement can have the subgrade, the sub-base, the road base, then the binder course, and then the wearing course. Altogether, this can be called the surfacing. So let's first get back to Civil 3D and then we set that. Pavement depth 1. So pavement depth 1 is going to be the wearing course. So we have not designed the structure of this pavement, but let's just give it something like 50 millimeters, which is going to be 0.05. Remember, these units are in meters, so it's going to be 0.05 meters. Then pavement depth 2, which is the binder course, let's give it something like 0. Let's just give it still 50 millimeters. We have not designed the structure of this. Then the base, the road base, let's give it something like, I think, let's give it 0.15. And then the sub base, let's give the sub base something like 0.2. That will be enough. So you don't have to worry about this. You have to design the structure of your pavement, but in this course we are not covering that. We are just giving random values. So let's continue. They use super elevation. So we are not going to use super elevation in this design. So let's set it to none. Otherwise, if you have to use it, then you would have to set it from here. Slope direction. The slope direction, it is sloping away from the crown. So this can also be changed, but it has to slope away from the crown. Then potential pivot. So the potential pivot, it's something like a parameter that is useful when you're applying super elevation, but you are not applying super elevation in this design. So we are going to set this one to no. And when you set it to no, these triangle signs here are going to disappear from our assembly. So let us set this to no, because we are not going to use super elevation in our design. So this is going to disappear from the subassembly. Inside point code. The inside point code is the crown, so leave it as crown. And then the outside point code, it's going to be the edge of the pavement. So in another case, you could have it as edge of lane, but in our case, it's the actual edge of the pavement. And then after setting those parameters, let's just click OK and accept that. So you can see that the triangles that were just somewhere above here have disappeared from our subassembly. So we have created the subassembly for our lane. Now we have to add on the subassembly for our shoulder. So we need to create the shoulder somewhere here to the right hand side. So let us look for the shoulder. So when you come back here to the tool palettes, we are going to look for shoulders. So shoulders is just somewhere there. If you cannot see it there, just come here, right click, and then look for shoulders. You still see it there. So there are different methods, different options that we have to use, but we are not going to go through all of them. We are just going to use shoulder extend all. Let's choose this one here, shoulder extend all. So click on it once. So when you click on it, it will give you a chance to set the parameters from the properties, or you can first add it there, then you change its properties from within the properties after you adding it there. Oh, let me talk about something. Now, in case you want to get more information about these assemblies, let me first close this. Let me first close that. In case you want to get to know more about these subassemblies, you can just come to the subassembly, you right click, and then you choose help. So when you click on help, it will show you, oh, I'm not online. So let me first get online so that I get the help. Let me first get online. In case you want to get help about any of these subassemblies, you can come to the subassembly, right click, then choose help. Now, in order for you to access this, you should ensure that you are online. Otherwise, if you're offline, you may not be able to access this help. So let me expand this. So when you go to the online help, this is the shoulder extend all. You can read about its properties from here. So here they are showing you that this is the percentage slope. This is the shoulder width, the daylight width, and then the daylight slope. So you can read about the different properties of these subassemblies from here. In order for you to access this, you should be online. And then you can read about all these input parameters. If you have time, we are not going to go through them, all of them. I'm just going to highlight just a few of them. So I want to talk about the points, the links, and then the shape codes. Now, these subassemblies have points, links, and shapes, which we are going to talk about just very soon. Let me first go back to my Civil 3D. Let me first close this. So when I go back to this, I want to talk about the points. So the points, if I expand this, if I zoom in, the points are these circles that you see on the subassembly. So if you see those circles that you're seeing there, those are the points. And then the links are the lines that you see. They are, if I zoom in here, you see something like a line. So something that you're seeing like a line here, these lines that you're seeing, those are the links. And then we have what we call the shapes. The shapes are these parts that are actually colored. The ones you're seeing here in yellow, blue, and so on. So those ones are the shapes. The ones that are colored. The ones that you see as the lines, those are the links. And then here you have what you call the points. Now, each one of those are used in different ways. So let's first go back to the help on this shoulder extend all. Let me go back to the properties of that. So when you go back to the properties of this, you'll see what each one of these represents. So you the, you can actually go there and you read about the properties of this on your own in your free time in order to understand more about this. Everything is provided there. So you have the type, the P, the code, and then the description. So you have P2, edge of pavement, finished grade. So you can actually come and read about them. The P's are the points, the L, L1, L2, L3, L4, those are the links. Then you have the shapes, S1, S2, S3, and S4. S1 being pave 1, pave 2, sub base, and then sub base. So you have the coding diagram here showing you where the points are, P1, P2, P3, P4, and the shapes S1, S2, S3, and S4. So you have the links here, L1, L4, L2, and so on. So you can actually take your time, read about them, and so that you gain more understanding of them. Otherwise, if you have not accessed the help through this, you can also access the help by clicking on the subassembly, click on the subassembly properties. Then within the subassembly properties, when you come to the parameters, you can see subassembly help on these 3 dots. So you can always click on these 3 dots just once, and it will take you to that web page for you to access the help. So this is the help for the lens elevation AOR. So you can read about its parameters, get to know more about what each represents so that you use them when you know what they represent. So you can take your time and read about them. So you have the points P1, they are telling you what each one of those represents. S1, this is pave 1, area between the finished grade and pave 1. So you can Actually, take your time and read about them. So let me close this and we'll get back to what we are doing. Next, we wanted to add the shoulder extend all. So let's click on the shoulder extend all. So it will bring for us the properties where we can change the properties of this shoulder extend all from here. If you want, you can change. So I actually want it to be on the right, the shoulder width and everything. We can set it from here, but I'm not interested in setting them from here. So let me just go ahead and add it here. So make sure you select this top point here, and then just click there once to add the shoulder extend all. So it has been added. Just click on escape and then select this shoulder extend all and then go to subassembly properties. So we are going to adjust the properties from here. So let us change the name of this subassembly and we call it shoulder right. And then we go to the parameters. So we are going to set the parameters from here. Remember, on our cross section, the shoulder width, which is represented by SW, is 2 meters. So this is the 2 meters. We are designing for the dimensions of paved 1B. So the shoulder width of that is 2 meters. So we are going to have a shoulder width of 2 meters and then the slope is going to be 4%. So let's get back to Civil 3D. Our shoulder width is 2 meters, but however, remember, our lane has extended into the shoulder by 0.3. So we are going to set the width here to be, let me first show you that on the section. On this section, the lane starts from here and it extends into this by 0.3 meters. But then the total shoulder width is 2 meters. So I'm going to reduce the 2 meters by the 0.3 so that from here up to the last point, it is something about 1.7. So I'm going to set my shoulder width to 1.7 meters. So our shoulder width is going to be 1.7 meters. And then use super elevation. We are not using super elevation. Shoulder slope direction, it's going to be away from ground. Then the shoulder slope. So our shoulder slope is going to be 4%. So make sure this is negative 4%. So it's negative 4%. And then sub-base daylight type, hold slope, adjust with it, leave it at that. And then the daylight slope. The daylight slope is, we have seen it, it is this slope here. So that slope here, we are going to have something like 2 to 1. So just set it to 2 to 1. Let's have it at that. Then the daylight width, you don't have to worry about this, just leave it at that. Then super elevate sub-base, no. Sub-base percent slope. The sub-base percent slope, we are still going to set this to negative 4%. So let's have negative 4%. And then pavement depth 1. Pavement depth 1. Now, normally, when you go back to the cross section, the pave 1 is the wearing course. Normally, we don't, in some places or in some regions, they can provide, but in some regions, they don't provide the wearing course on the shoulders. So we can set that pave 1 depth to 0 so that we don't have it here on the shoulder. So let's first get back to Civil 3D. So we can set the pavement depth 1 to 0 because we are not going to have the wearing course on our shoulder. In some regions they can have, or we can choose not to have. So you really don't have to worry much about this. Don't worry about these parameters. In your design, you can put whatever you want. You know, this is your design. So pavement depth 2. So I'm going to set this to 100 millimeters. I have set this one to 0, which was initially 50. So I'm going to add it here, and I have 100 millimeters. So that is 0.1 meters. Then the sub base, sorry, the road base. The road base, I'm going to have 0.15 like I had before. And then the sub base, let's have it like as 0.2. So these are the parameters we are going to use. We are going to have sub base slope negative 4%. We're going to have pavement wearing course as 0. This one 100 millimeters, 150, then 200 millimeters. So I think we are okay with that. So just just click on OK, and then we accept that. So we have successfully created our shoulder. So we are not going to have this top, the pave one on this shoulder. We're not going to have the wearing course on our shoulder. So this is just what we are going to have in our cross section. Now the next thing, we have to add the daylight on our shoulder. You have to add the daylight on this assembly. So normally, beyond the shoulders, we are going to have what we call the daylight. So the daylight is that point where your design will stop and it will intersect with the existing ground. So where your design is going to stop and to where it's going to intersect with the existing ground, that is where you'll have your daylight beyond your design. So we are going to add on what we call the daylight. So normally in urban areas, we normally have curbs and gutters. But in rural areas, when you're designing, normally we just provide shoulders and then we terminate it with the daylight. But in urban areas, you can have curbs and gutters. So in this design, we are not going to use curbs and gutters. We're just going to add a shoulder. So when I talk about the daylight, this is actually what I'm talking about. That this is where your design is going to terminate. If your design terminates here and this is the existing ground, so where it will intersect with the existing ground, that is the point where we shall have the daylight. So this is the target surface, which is the existing surface, and then the daylight is that where your design is going to terminate and intersect with the existing surface, existing ground surface. We are going to add the daylight. So our design is going to terminate, and then we are going to add the daylight at this point here. So let us look for the daylight among the sub-assemblies. So you can see there's a tab here for daylight. Just click on that. Still, if you can't see it, you can right click and then look for daylight. You'll be able to see it there. So we still have different options here. If you don't, or if you want to understand more about each one of these, you can just come on the option, right click on this sub-assembly, which is the daylight, and then you click on help. So once you are online, you'll be able to access this web page with the help concerning that particular sub-assembly that you want. So you can come here and you read about its properties. I'm not going to look at that. So let us choose the daylight bench. We're going to use the daylight bench. So when you choose that, it will bring for you the properties. I'm still not going to change the properties from here, but you can choose to change them from just here. I'm not changing the parameters there, so let me close that, and then we are going to add it on this point of the shoulder here. So just click here once, and then your daylight is going to be added at that point. So just escape and then select this daylight bench. Then go to the sub-assembly properties. We want to change some of the parameters from here. So we are going to call this one daylight right. Let us change the name to daylight right. It is always a good practice to give it a name that describes it, because later on when you are setting the targets, you will need to refer back to what you're actually dealing with. So if you have not named it properly, you will get confused. You can add a description if you want, but I'm not adding. Let's go to the parameters. So the parameters, it is on the right hand side. Yes, we are leaving it on the right hand side. Then the cut slope. So the cut slope, let's leave it at 2 to 1. Yes. The maximum cut height, let's leave this as 3 meters. Fill slope 2 to 1. Maximum fill height, leave it at 3 meters. The bench width is 1.5. That's okay. Bench slope, let's leave these ones as default. Rounding option, let's just leave all these as default. I'm okay with these parameters. Let's just leave them for now, and then yeah, we can just accept this and click OK. So we have successfully created the right hand part of our assembly. So we need to create this same design on the left hand side also. So you can choose to create them, each one of them one by one, but there's an easier way how you can do that. So you can simply just highlight this. After highlighting that, you're going to, on the contextual ribbon, you can see that there's an option for you to mirror. So click on that. However, if you use the AutoCAD command for mirror, it may not work here. So make sure you're not using the AutoCAD command of mirror. Just use the one on the contextual ribbon. So when you click on that mirror, it will tell you to come and select. So we are going to choose this as our point here, to mirror about this point. So select on this baseline once. Then you get these notifications. You don't have to worry much about these notifications. You can read them. And then you click on that green tick. So our sub-assemblies have been mirrored, and now we have our assembly created. However, we still need to change. I need to look at the properties of this and we change something. So you can select on this baseline. So instead of clicking on the sub-assembly properties, you select the assembly properties so that we edit all the properties at once. So we are in the assembly properties. The information, so the assembly is called the roadway assembly. Let's go to construction. So these are we have the baseline, and then the baseline has the sub-assemblies. So we have the sub-assemblies on the right-hand side, and then we have those on the left-hand side. So you can see that we need to rename. Remember, we have just mirrored the ones on the right to the left. So we need to change the names of these to the left. So let us name this lane left. So just click this once and then change the name to left. So come to this and also change to shoulder left. Then this one also daylight left, because this is on the left hand side, this is on the right hand side. So it should correspond to the side where it is, so that later on we don't get confused. So this is left. Yes, and other properties, we are leaving them just the way they were. So I'm okay with all the other properties. So we are leaving them just the way they are, and then we just click on OK. So we can close these tool palettes. So we have successfully created our assembly, our roadway. Now in a real project, you might have to create more than one assembly. You can create so many other assemblies, but this is just a simple project. We are going to have only one assembly and we apply it throughout. All right. In the next section, we are going to see how to create our corridor. Also, if you have found this helpful, make sure you subscribe, like, and share to your friends. Thank you for watching.